Okay, question 10, the other differentiation question, much bigger question. And again, we've always found that the core one questions that students find the most difficult, the area that you can get most stuck on these, are where you get a question that's lots of marks with not much to go on to start with. And this is kind of the worst that you can get, to have really one line of writing, one line of information, and then just 10 marks. No guidance about how to work your way through it, nothing about that at all, just straight into it. Right, find the coordinates of the point on the curve at which the tangent is parallel to that line. So it's about finding a tangent. It doesn't say differentiation, but it is. As soon as we see that it's about finding a tangent to a curve, then it must be a differentiation question. The tangent is parallel to that. So the gradient of that line gradient of the line y equals 8x plus 3 is 8. So that's what we're going with. We want our tangent to have a gradient of 8. We need to find the coordinates of the points on this curve at which the tangent is parallel to that. So we want to know, when is this curve having a gradient of 8? So our next stage is to differentiate it and see what we can get. Now, just like what we've just done in the previous question, we need to write this in a convenient form to differentiate. So this is a third x cubed. Now, how are we going to write 9 over x? 9x to the minus 1. Okay, so that's the first bit. Now we're going to differentiate it. dy by dx is 3 over 3 times x squared. And then this would be minus 9 x to the minus 2. Now I think, before I do anything else, I want this as being x squared minus 9 over x squared. Put it back in that form, because that's what it looks like. And just, as we're going into this, we're thinking, well, 10 marks, that's a lot to have in this. We've differentiated. We haven't done anything about stationary points in this question, in this paper. There's another big thing that is on almost every paper that we haven't met yet, and this is the last question we're doing. And the other big thing was in part of polynomials, and we didn't mention it at that point, but the stealth quadratic idea. So when we see this for 10 marks at the end, by this time we're kind of thinking there's a couple of things we haven't done on this paper yet. Stationary points, stealth quadratic, it's probably one of the two. We're heading for a point where the gradient is supposed to be 8. So that means the gradient, x squared minus 9 over x squared, is equal to 8. And can you see we have ended up with a question that's about stealth quadratics. We've got an unknown on the bottom of the fraction. Our next move would be to multiply everything by x squared. So x to the 4 minus 9 is 8x squared. And if we bring everything over to one side, we've got x to the 4 minus 8x squared minus 9 equals, equals 0. Now, you may be confident enough to just go straight into factorising this as it is with x squared in there, or you may be somebody who wants to write this with another letter in there, maybe using the letter t. You could write it as being t squared minus 8t minus 9 is 0. They have at least been kind enough to give you a thing that will factorise without too much difficulty. Two things that multiply to give minus 9 and add to give minus 8. It's going to be minus 9 and plus 1, isn't it? So we've got t minus 9 d plus 1. And so we've got that t equals 9. T equals minus 1. But then we undo, if we have done a substitution, we undo the substitution and go back to saying that really means that x squared equals 9 and x squared equals minus 1. Well, over here we know that x squared equals minus 1 has no real roots. There are no values of x such that you could square it and get minus 1. So there are no real solutions to that. But over here we've got x squared equals 9. And again, it's the end of the paper, we're rushing a bit, we're thinking, wow, we're nearly finished, it would be so great to get out of this. X squared equals 9, we've got to be careful that we don't just write x equals 3. X equals plus or minus 3 as our answer to that. Now, what have we got to do with this? We found the x values. Find the coordinates of the points on the curve at which the tangent is parallel to the line y equals 8x plus 3. So we've found the x values, we haven't found the coordinates. We need to go back and find the coordinates for it. If x equals 3, y is, what was our equation? Let's see it anymore. A third x cubed plus 9 over x. So a third x cubed plus 9 over 3, or good recovery, which gives us, good recovery-ish, a third of 3 squared would be 3. 9 over 3 would also be 3. So we've got one coordinate. Have I done something wrong? It's cubed. That's cubed, isn't it? Ah, man. It even says cubed. So that's now a 9. That was the tablet. It just wrote the wrong thing. Wasn't me. 9 plus 3 isn't 6.
That question.
Yes. Right. You see, attention to detail. It's so easy, isn't it, to make the little mistakes at the end of your paper. X equals minus 3. We get y equals a third of minus 3 cubed plus 9 over minus 3, which gives us minus 9. Minus 3 cubed plus minus 27 over 3 is minus 9. Take away another 3. So we get minus 12. So our other solution was minus 3. Minus 12. And there we are. They were the two coordinates. Actually, wasn't that bad, was it? At the end of the paper. That's core 1. And that's maths.